Hi everybody, welcome to test 1 review in calculus 2. This time, instead of the note, we have the problem will be on that side. Alright, so just run to it. Number 1. By the way, the numbers will be right here. Find the derivative. Right, so we have a function natural log of 2x squared plus 9, and so the function is the natural log or the ln. Put the parentheses. So the derivative of the ln is the reciprocal function 1 over, and then derivative of what inside the parentheses. We have 2x plus 9 and 2x squared plus 9. 2x squared plus 9. Right. 1 over 2x squared plus 9. Derivative of 2x squared plus 9 is 4x. And we can put 4x on the top. Right. Notice that the 4 and the 2 cannot be cancelled because of the plus 9. Right. So let's type the answer here. Actually, run this before, type the answer before and for test run. So make sure it works. Right, 2x squared plus 9. Sorry, plus 9. Right, so that's good. By the way, we certainly can type everything on the keyboard. So what I do is enter 4x and then the / x square, and then hit the next button and then plus 2x squared and then plus 9. Right. And the head, of course, is the shift button, and number 6, that's the / Right. I said I did this before, but let's do this again. I did this before I hit the record button, that's why. Right, find the derivative, the function of the function 3 cotangent of 4e to the x. Right. So the function is 3 cotangent 4e to the x. So when we take derivative, using the chain rule, derivative of cotangent is negative cosecant square of something, and then derivative of that something, and then the 3 in front of it. So let's just write like that. Right, we have 4e to the x inside the parentheses, the 3 in the negative, -3 cosecant square 4e to the x. derivative of 4e to the x is the same thing. 4e to the x, e to the x derivative is also e to the x. And if we want to, we cannot, this is the argument of the cosecant, so we cannot multiply the 4 with this 4. What we can only multiply is this and negative 3. This doesn't have any power, it's just the parentheses by itself, so we can combine with the negative 3. So negative 12 e to the x cosecant square 4 e to the x. Right. Having said that, we can just enter this in the calculator, I mean in the answer. So we have negative 3 cosecant square 4e to the x, and then times 4, we don't even need to type multiply e to the x. That they also take it, as long as we have something similar to it, the answer should be fine. Right. I also did this before I hit the record button, so determine the integral. X to the 8 cosine x to the 9 dx. Right. So to do substitution, we need two things. The first is u, and the second one is dx. So we'll let u equal to x to the 9. And then in order to find dx, we'll take the derivative. So derivative is 9x to the 8 power. Right. Usually whatever we let equal to u, when we take derivative, that should cancel with the rest of the problem. We should cancel with all the x. All the x should be cancelled. Right. So derivative x to the 8 should cancel with x to the 8. So that way we see, that way we know the substitution is correct. Right. Now I multiply the dx over and then divide by the 9x to the 8. And that equal to dx. So we need two things, u and then dx. Right. And we substitute back in x to the 8 cosine instead of x to the 9 power, we use x to u, and instead of dx we use this. X to the 8 cancel out. The 9 is a constant at the bottom. Bring outside, still stay at the bottom. Have to put 1 on the top though. Cosine of u du. The integral of cosine is negative sine. And that will give us negative 1 over 9 sine of u, where u is x to the 9 power plus c. Right. let's see, negative 1 forward slash 9 sine x to the 9 power plus c. Right. So I guess we have to enter sine x to the 9 power close parentheses. Of course, there's nothing wrong with that. The integral is of cosine sine. Sorry about that. Right, we're good. Sorry. Right. So integral cosine sine. Right. Before evaluate I see. Yeah, we confused the problem with I did before. Anyway, right, on this one we also need to do substitution. Before I do that, I will put the dx on the back. We better that way. And then the substitution, we will let in below the denominator be u. I will take the derivative and then solve for dx. Derivative of that is just 8. Move the dx over and then divide by 8. For the review, I will go a little bit faster than the regular class because this is recorded. You can always rewind it if you need to. Dx is du over 8. The constant and we'll take it outside, and integral of 1 over u is ln absolute value of u plus c, so it's 1 over 8 ln absolute value of ax plus 7 plus c. Right, let's try to type without the absolute values. Let's see if they take it. 1 divided by 8 ln parentheses ax plus 7 plus c. No. So they want the absolute values. Right. So it has to be absolute values. That's number 5. Evaluate 60 square e to the negative t cube dt. Right, so this is also substitution. So what we substitute is something when we take derivative should cancel with the problem, with the t in the problem. So if we let u equal to t cube, negative t cube here, derivative of that is t square, which cancel with this t square. So that is good substitution. Right. Let u be negative t cube, and then we take derivative. Move the dt up. And divide by the negative 3t squared. So we have u and we have dt, which is good. And then we have a negative t cube, so that is u. dt is this. T squared cancel out. Negative 3 constant at the bottom, and the 6 constant. The 6 is on the top, the negative 3 at the bottom. So just say 6 on the top, negative 3 at the bottom. And we have, just make sure, right, we have e to the u du. 6 divided by negative 3 is negative 2. Integral of e to the u is e to the u plus c. And u is negative t cube, negative 2 e to negative t cube plus c. Negative 2 e to negative t cube plus c. Right, that's good. Yeah, I think that better. Right. Next, find derivative of the inverse trig function. The function is sine inverse 5x to the 5th. There's a formula for sine inverse, but I prefer not to use it. I should say I prefer not to memorize it. So we start with that. I will write 1 instead of f of x. What we do next is we're going to take sine on both sides, because that will undo the sine inverse. So we have sine of y equal to 5x to the 5th. what we do now is we will take derivative on both sides. Derivative of sine y is cosine of y, but because y is a function of x, so we have to have the y prime. So that is the chain rule, or more specifically implicit differentiation. And we'll take derivative on this side as well. That will be 25x to the fourth. So what we did is differentiate with respect to x, and y is a function of x. Right, so that's what we have. And then we divide by cosine of y. So we have y prime is 25x to the fourth. This is multiplying. So we'll divide by cosine of y on both sides. Right. All we need to do is find out what is cosine of y. For that, we will draw a triangle. Right. Right. We're going to take this part and we'll draw a triangle for it. Where the angle is y. Right. So sine of y is equal to 5x to the fifth over 1. I write that as a fraction or ratio because sine is a ratio of opposite over hypotenuse. So opposite of the angle y is 5x to the fifth and the hypotenuse is 1. Because of that, the equation is 1 square minus 5x to the fifth square, or maybe 1 minus 5 square, 25. X to the fifth square will be x to the 10. Right. If that is sine, then cosine of y. Cosine is adjacent over hypotenuse. Look like there's some problem with the software. Alright, adjacent that. (25x to the 10). Hypotenuse is 1, right? Divide by 1, so it itself. And that is cosine of y, so I put it back in here. That's all we have. Right. Right. So let's type that answer in. If I hit the forward slash, give us a fraction, 25x to the fourth, and the square root is the backward sqrt, the backward slash sqrt, 25x to the 10 power. Right, that's good. Yeah. There's some fan drop because I opened too many windows at the same time. But other than that, I think we're still okay. Right. Evaluate this. Okay. That is number 7. L'Hopital rule for this indeterminate form. So find the limit. So we try to do that. First, so let this equal to y. Right. First thing, when we do the find the limit, try to put in the numbers and see what happens. When we put in 0, what we have is 1, 3 times 0, 5 divided by 0. So 5 divided by something that goes to 0 is actually to infinity. So what we have is indeterminate of the form 1 to infinity, which is indeterminate. Right. So we let that equal to y. We're going to use the L'Hopital rule. Do is when have to take care of that power. So in order to take care of the power, what we do is we will take the ln on both sides. For that, I can check the ln inside the limit. And we can check the exponent outside. So I have limit x go to 0, 5 over x ln 1 plus 3x. So on the top we can say 5 ln of 1 plus 3x. At the bottom x. Right. Now we'll take derivative. Now we haven't done any L'Hopital rule. Now we will use the L'Hopital rule. Take derivative of the top and then derivative at the bottom. Derivative of ln is 1 over parentheses and then derivative of that. Inside the parentheses 1 plus 3x, 1 plus 3x. Derivative of x at the bottom is just 1. Right. Simplify this. We have 1 over 5 multiply on the top 1 plus 3x, and derivative of 3x is 3 divided by 1. We don't really need to do right like that. We just say limit when x go to 0, multiply the 3 on top, we have 15 over 1 plus 3x. And then derivative, all of that divided by 1. But we don't need to do right like that. So it's this. Next we're going to put 0 into x. 15 1 plus 3 times 0. That's just 15 over 1. Or 15. And we make the limit equal to that. Alright, that is not the answer though. What we have is ln of y is equal to 15. To get rid of the ln, we will take the e on both sides. And e and ln cancel out. We have y equal to e to the 15 power. Right. That's that. Right. Next, comparing the rate. That's number 7. We compare x to the 6 and e to the 0.05 x. Right, so which one is go faster to infinity? So what we do is we just take the ratio of them. I take x to the 6 on the top and e to 0.05 x at the bottom. Let x go to infinity and see which one go faster to infinity. I'll put infinity in it. That's the first thing we do. X to the, which is infinity to the 6th power over e 0.05 infinity. And that is indeterminate, so we have to use the Hospital rule. Using the Hospital rule, take derivative of the top 6x to the 5th and then derivative of this e to something and derivative of that something 0.05x 0.05x 6x to the 5th and e to the 0.05x and 0.05. Right, the 6 and divide by 0.05. Certainly we can do that, simplify, but we don't have to do that. Now, the point here is if we put infinity in here, it's still infinity over infinity. So we have to take the derivative. We have to use the Hospital rule a few more times. Right, take out the 5. So rather than write 30, I just say 6 times 5. X to the 4th. And then the bottom we have e to the 0.05x derivative, and then that constant, so we have 2 of the 0.05. And if we put in infinity, that still doesn't work, so we keep doing that. And we use the Hospital rule a few more times. How many times do we need? Let's see. So we take out the 6, have x to the 5th, take out the 5, x to the 4th. Now take out the 4th, we have x cubed, take out the 3, we have x squared, take down the 2, x, and then 1, and then x to the 0 power. So we do that 6 times total. And at the bottom we have, this is 2 times, and let's see, 1 2 3 4 5 6. At the bottom we should have 6 of them. Right, 6 times all the way to 1, that is 6 factorial, so it will be 720. Where's the limit? $720, and x to 0 power is 1, so just 720. E times 0 to e to the 0.05 power, and then 0.05 to the 6 power, that equal to something. Right. Now we put in infinity. 720 infinity times 0.05, still infinity. Even though this is a very small number, but that's still constant. So what we have is a constant or finite number divided by infinity. So what we have is finite amount divided by infinity. That of course is going to be 0. Not only that, what we see is the top is going to be finite, the bottom is infinity. So obviously the bottom will go faster than the top. So e to the 0.05x goes to infinity faster. Right. So this one grows faster. Yeah. Right, here's number 9. Right. Oh, this is not going to be easy. I hope I can make it work. Oh, that's bad. Sorry. I need to delete this real quick. I'll try that again. Right. At least we have that. Okay. Temporary. That's what we have. So find the area. Of the shaded region. not even zoom in. Right, we have y equal to 5, y equal to x, so that one. Y equal to 5. And y equal to x squared over 20. Looks like the intercept at 10. Right. So there are two ways to do this problem. First one, let's just give it like this, and we use dx. There's also we can also use dy. Use dx for this one. Right. So now, so this is the region, right? So now if we use dx, this is going to be above the function above minus the function that is below, and then dx. The limit for x in this case, that easy, from 0 to 10. Now, the region above minus the region below. Now think about this. If we talk about this part here, for this part, the function above is this diagonal line, the function below is the curve. So we have that part. But for the other part, see if different colors, if I have it. The other part. Now for this part here, the function above is the straight line, the horizontal line. So those two regions, we have to use different boundary. This region here, the boundary on the top is the horizontal line. This region here, the boundary on the top is the diagonal line. So what we have is, if we want to set this up, it is going to be integral from 0 to 5. The function above is the diagonal line, y equal to x. The one below is x squared over 20. And then we have to go from 5 to 10, where the function on the top is y equal to 5. The function at the bottom, x squared minus 20. Dx. Right. That's how we set it up. Now I just use a calculator here. Math, option number 9, integral from 0 to 5. X minus alpha, zoom, reverse a fraction, x squared, wrong button, divided by 20, dx. What did I? Oh. Can I get a fraction? Yeah, 125 over 12. and then of course the other integral does not change too much. So same thing, hit enter, copy and paste, and let's see, we go from 5 to 10. Instead of x, it's going to be 5, and the rest stay the same. Oh, it's the same. Right, change that to fraction. Okay, 125 over 12. So pretty much those two are the same, so we just multiply by 2, which is 125 with 6. Right, that's one way to do it. The other way is using dy. If we use dy, it will be the function on the right minus the function on the left, dy. In this case, we know the y limit will be from 0 to 5. Right, now let's check. If we use dy, it may be difficult to see, but now it's not too bad. As you see, all of them, it is bounded on the left by the curve and on the line by the diagonal line. So one boundary on the left, one boundary on the right. So we only need one integral. The right function is something, but it has to be in terms of y. Just put that here. Right, now it has to be in terms of y. Y equal to x or x equal to y. So that first part is easy. X equal to y. Subtract. This have to be in terms of y as well. So we solve for x. X squared is equal to 20y, and we take the square root. So x equal to square root of 20y. That should be plus or minus, but this part is positive, so we just have square root of 20y. Right, let's try that too, see what happened. Math number 9, go from 0 to 5. I just use x here instead of y, just the values. Square root of 20x. Still the same thing though. Right, we have negative simply because that's not what it's supposed to be. The function on the right, square root of 20y, minus the function on the left, y. So they have to be like this. Let's do that again. The area cannot be negative. Right. Square root of 20x minus x. Right. Can we convert to fraction? Likely not. Right. But is that close to 125 divided by 6? Exactly, very close. So when the calculator do this approximation, it is a little off, but the answer should be either way, 125 over 6. Right. That is correct. I just didn't show it. Right. Right. Next. Find the area between y equal to 2x squared and x squared plus 9. Can I do this? Yeah, that certainly works. Right, so we have y equal to 2x squared and x squared plus 9. So we just, that's what we know, we don't have the graph. So first we have to find the intersection. Y equal to 2x squared and y equal to x squared plus 9. So both of them we make equal to 9, I mean equal to y. And then we solve for x. Move the x squared over x squared equal to 9. Take the square root on both sides. So the intersection is plus or minus 3 at x equal plus or minus 3. When x equal to 3, let's do minus 3 first. We can just put negative 3 back into either one of this. I use this one. That is 18. When x equal to positive 3, that also 18. Right. Let's see the graph. Y equal to 2x squared, parabola that open up, and this also another parabola that open up. Right. We have to zoom out in order to see the whole graph. Zoom out. Right. So the sketch, let's say about negative 3 to 3. Right. If we want to zoom the windows, we can always do that. Zoom box, and let's zoom about that. Right. So look like there is one very skinny and then the other one kind of right. So bottom line is the one at the bottom is 2x squared. Now to set up the integral, this will be very easy. We set up using the x. The function above is y equal to x squared plus 9. Subtract the function below is 2x squared. Integral will be from negative 3 to 3. So we will have negative 3 to 3 and x squared minus 2x squared, so minus x squared plus 9 dx. Right. Math number 9, the integral. If you have this kind of question on the test, if you have a calculator, it's perfectly fine to use them. If we have the answer come out nice and even. Certainly we can do that. Right, that's good. Right, next. Oh, that doesn't work. Try this again. Right. So that is the problem. Right, so we have y equal to x squared, x plus y equal to 6. By the way, this problem I created myself. It's not from the book. That's number 11. Right. Wrong window. Okay. We have x plus y equal to 6. So 2, 4, 6. X plus y equal to 6. And then y equal to x squared. And then the x-axis. Right, so we're talking about this region here. Right, so let's set up the limit. Right. Right, now, if we use the dx, that will be the one above minus below. The point of that is if we use dx, which is horizontal, right? We have to have the height to have the rectangle, and the height will be the function above minus the function below. With that, we have a rectangle to find the area. Now, if we're using dy, which is vertical, we're going to need the horizontal counterpart. Not counterpart, but we need the horizontal to make a rectangle. And that one will be from the right minus from the left. So that's why we have these two things. Those two formulas. Right, now let's go with the x first. If it is x above and below, the function above, from here, the one above is the parabola, but from this point on, the function above is x plus y equal to 6. So the boundary, there are two of them above. We need two integral for that. let's say if we look at sideways, left and right. If left and right, on the left it is bounded by, just if we look from left and right like this. On the right it is bounded by the diagonal line. On the left it is bounded by the y equal to x squared. So we only need one integral. So here we need one integral, and here we need two integral. As far as the limits go, now let's go with the dx first. So for dx, we need two integral, and we have to split it right here from 0 to 2. The one above is x squared, the one below is 0. That's it. This equation, the x-axis, y equal to 0. The second part, this one, integral from 2 to 6. The one above have to be in terms of x. If y equal to x plus 6, x plus y equal to 6, then y equal to 6 minus x, and that is the function above, minus the function below is 0. So that's pretty much it for the x. 0 to 2, x squared dx, 2 to 6, 6 minus x dx. And then for dy, we only need one integral. And y go from 0 to 4 on the y-axis. Right, the function on the right, y equal to 6 minus x. Now we solve for x. This function can also be written as x equal to 6 minus y. We need dy, so we need the function of y. So on the right we have 6 minus x, and on the left we have y equal to x squared. Need to write this as the function of y. X equals square root of y. Right, so let's try that. Right, so we need to split the limit for dx. Yes, we do need, and we will split at 2. Let me make this bigger. We split at 2. So to go from 0 to 2, and then from 2 to 6. The function, first one is x squared, and then 6 minus x. And on this one, we have 6 minus, I guess it have to be y, because y is the variable. So 6 minus y minus square root will be x slash xqrt. Alright, good. So that's what we have. Right, next we also have a similar problem with the region. Yeah. So I also created this problem. Try to draw this. Right, y equal to x squared, that is the problem. Right. Yeah, sorry, that's a little not as okay. Yeah, the y equal to x squared, actually it has the other part too, but I just have, so the what I'm trying to say is the graph is not, I mean the graph is good, but the function, the x squared, will have the other side as well, so it's not a very good problem. But it's not wrong, because we're talking about this region here. We have y equal to negative x. Y equal to x squared, the curve, and y equal to 4. Right. Now, so we set the integral again. Above minus below. If we use dx and right minus left, if we use dy, and I apologize for the video kind of choppy because of whenever I open my MATLAB and I try to record it, so look like I need to update something. I'm trying to close these windows. I opened a few more windows than I need to, and go with the x first. For the x above and below, the function above, that's clear, just the horizontal line. The function below, there are two of them, one of which is a horizontal, I mean the diagonal line, and the other one is the curve. So we have to split the limit for the x again. Right, so we go from negative 4 to 0. The function above, is 4. The function below is negative x. And then the integral from 0 to 2. The function above is 4. The function below is x squared. Yeah, so yeah, above y equal to 4 minus negative x, and over here 4 on the top, x squared at the bottom. So simplify 4 plus x dx, and 0 to 2, 4 minus x squared dx. So if we use dx, now if we use dy, for dy, on the right is y equal to x squared, and on the left y equal to negative x. So on the right, so if we use dy, limit for y will be from 0 to 4. Y equal to x squared equivalent to x equal to square root of y. That is the function on the right. And the function on the left. Y equal to negative x, or x equal to negative y. Right. I don't know why a regular stream is fine, but when I try to record it, slow down significantly. I think I have to shut down the face cam so that it will go smoother. Right, let's try this. Right. We have to split the dx, so split the dx, split at 0. And we have 4 plus x. Four minus x squared. And for dy, square root of y, sqrt y plus y, oops, plus y. Yeah. Right. So let me turn off the face cam. Maybe the quality is better, I hope. Right. Next, this is 13. Find the volume of the solid. So we have the graph there. So the quality doesn't improve. Obviously there's something wrong with my computer. So you think the problem with the MATLAB, because that is constantly updating the website. Right. Y equal to 2x and y equal to a square root of x. Right. Y equal to 2x let's graph it first. Really, for some reason I don't know why it's so choppy. We have 2x and a square root of x. Just graph. Zoom number 6. Right, they're not intersecting, so zoom out. Right, that's good. Let's zoom back in. Of course, if we want to find the intersection, y equal to 2x, and that equal to a square root of x. Square on both sides. That gives us 4x squared equal to 64x. Move everything on one side. Divide by 4. X squared equal to 16x. Move everything on one side and factor out the x. So we have 0 and then 16 are the intersection. Right. So we have that. Now this one rotates about the x-axis. Right. Now if we rotate about the x-axis, so this is for the area. Now if we talk about rotate about the x-axis, now if we have the axis of rotation, and if we use the dx, that is going to be the distance washer. If we want to use the shell, it will be perpendicular to it, and that will be dy, and that is for shell method. So here we use distance washer, so we're going to stack alongside the axis of rotation, so that will be dx. So the volume is equal to pi r square minus little r square dx, go from 0 to 16. Right. The big radius go from the axis of rotation to the edge of the function a square root of x. So we have 0 to 16, then pi. The function, the big radius, a square root of x. At the bottom, the smaller radius from the axis of rotation to the edge. So that little r equal to 2x on the top minus 0 at the bottom. This one should be minus 0 as well. So either way, we have a square root of x, the big radius square, minus the bottom or the little radius square will be 2x, and then dx. Right. I will take out the pi, 0 to 16, and that gives us 64x minus 4 x squared dx. Right. I'm going to use the calculator. Math number 9. I will leave out the pi. Just go from 0 to 16. 64x minus 4x squared dx. Can we get fraction? Oh shoot. Just have to do this by hand then. Right. After this one, I have to restart my computer and see if I can fix that. Right, integral of 64x is 64x squared over 2, and integral of that is 4x cubed over 3 from 0 to 16. So that gives us 32 x squared minus 4 over 3 x cubed 0 to 16. Right, put in 16 and put in 0. We should have just 0. So we will have pi times 32 times 16 squared minus 4 thirds times 16 cubed. (32 times 16 squared) (192), and then 4 times 16 cubed. Which is twice as much. Really? Yeah, look like that. Divide by 3. Right, multiplied with common denominator. And we just have a192 over 3 with a pi. Okay, pi times a192 pi divided by 3. Right. I have to restart the computer. Maybe it will go faster. Right. Right. We continue. Number 14. Let the region bound by the curve and right. This one abroad. Y equal to 0. The x-axis, y equal to square root of x divided by 5. So square root of x divided by 5. Right, and then x equal to 45, so we know that's going to be up to 45. And let's see, y equal to square root of x over 5. x equal to 0, that's 0, 5 be 1, and 45 by 5 is 9, square of 9 is 3. So oops, yeah. Right, 5 and then also between the y equal to 0, so the x-axis. So we're talking about this region here. It is rotated about the y-axis. Right, now earlier we have, if we have the horizontal axis of rotation, the distance washer method will be along it, the share method will be perpendicular to it. Now we'll do one more for when we have the vertical axis. Axis of rotation. The disk or the washer method will be parallel to it, which is also vertical, so it's going to be dy. And the share method will be perpendicular to it, will be dx for the share method. Right. So axis of rotation will be parallel to it if there's a distance washer, and perpendicular to it if it is a shell method. So this problem did not tell us if we have to use the shell or the disk or washer method. Right. So I'm going to do both. So let's use this and washer method. This is the axis of rotation. So this is a washer method. We used to chop that axis into a bunch of little pieces. So in that case, this washer method, that's going to be dy. Y goes from 0 to 3 in this case. Just need to determine the big radius and the little radius. The big radius, the radius is always from the axis of rotation to the outer edge. So big radius in this case is 45 on the left and 0 on the right. Yeah, that length. The little radius from the axis of rotation to the function. And the function on the right, this has to be in terms of y, so we have to solve for x. S square both sides and multiply 5. X equal to 5y squared. Right. Look like it works. I mean the setting. So the function on the right minus the function on the left in terms of y, so be 5y squared minus 0, 5y squared. So those are the radii. 0, 3 pi 45 squared minus 5 y squared dy. Right. And now let's say the shell method. The same method, if this is the axis of rotation, the same method we use the one perpendicular to it, which is the x. Two pi r h dx, x go from 0 to 45. Right, now the height. Now the shell method is different. What we do is we're going to draw the height in the region. That is the height, which is bounded above by square root of x divided by 5 and bounded below by 0. So the height is easy to determine. Above by square of x minus over 5, the bottom by y equal to 0. Right, just that. Now, the radius, the big R, is the most difficult to set up here. So what I do is I will take any point on this line that I drew. That point we have the x coordinate and the y coordinate. Right? Now, the x coordinate is the distance to the y axis, and the y coordinate is the distance to the x axis. Since this one is the dx, we only use x, not y. Right, so if this is x, and now the only thing we need to check is what is the distance from that point to the axis of rotation, will be just also x. In the next problem we might not have this case, but anyway we will have 0 to 45, 2 pi x square root of x over 5 dx. Either way works. I'll use the one for the y because I don't have to deal with the square root. Right, leave the pi out of it. Alright, I need to change this real quick. I have to reset everything, and that's why there's some problem. Also change the color of the calculator, maybe that helps. Right, math number 9, that goes from 0 to 3, (45 square) minus 5y square. I use x instead of y square. Right, that, and then stick the pi to it. So 4860 pi. To enter pi we enter backslash pi. Right, good. We can also do this. Right, let's try that. Math number 9, I will leave the pi out of it. 0 to 45. There's still a 2 x square root x divided by 5 dx. Yeah, should get the same thing. So we have y equal to 11x minus x squared, and y equal to 0, the y axis. wait, the x-axis. Now we try to rotate this about the y-axis. And for that, and this one we have to use the shell method. Right. Oh, it's nice enough. Give us the intersection 11. Right, close enough. All right. Rotate about the y-axis. Right, now, vertical axis of rotation. If we use the dishwasher method, that is going to be dy, stacking along that. If we use the x, it will be a shell method. On this one, they ask for the shell method, so they will have a shell method. Alright, shell method. And in this case, we use dy. So 2 pi rh, and we use dy. Sorry. Use dx. X go from 0 to 11. Right, determine the R and H. So what we do, kind of like what we did earlier. We draw a height. And that height, the boundary above by the function. And bounded below by y equal to 0. So just 11x squared, 11x minus x squared. Right. Now pick any point on the line, on the height. Right. It could be that top point or the bottom point or any point in between. Let's say try this point then. We have the x coordinate and then the y coordinate. The x coordinate is distant to the y axis. Since we want the x, we're going to use x. Now we rotate about the x axis. I mean the y axis. Now, once we draw the x, what's next to determine is what is the distance from that point to the axis of rotation. It just happened to be x. Shoot, this is the height. The R is going to be just x. So put all together, we have the volume 0 to 11, 2 pi r is x, and h 11 minus x squared dx. So they just want to set it up. We use the x. Sorry, you don't see that. Right, so we use dx. Limit from 0 to 11. And will be 2 backslash pi x 11 minus x squared close. I just enter it correctly, 11x. the volume is I hate when this happens. Right, I just evaluate this. Math number 9, 0 to 11, 2 pi x 11 minus x squared. Remember, we take the pi out of it. Once again, we need to enter that correctly. The answer not supposed to be negative. Right, can we change this to fraction? No. How about 2440 and then plus? Right. What is that? I didn't have enough to 6, so that would do it. Right, 16 plus 2440 pi times 2440 plus 16. Times 6 plus 1. Okay, 14641 pi over 6. 14641 pi divided by 6. On the test, if there's a problem like this, and if you got that integral right, you got like 90% of the problem, because that answer is not really that important, right? That 15. Next problem. So let R be bounded by these curves, so we have the functions. Use the shell method again. Okay. Right, y equal to 6 minus x. Y equal to 1. And x equal to 0. The vertical. We'll talk about this here. That is the script region R. Right. Use the shell method about the x-axis, so it will be rotated about the x-axis. Now the shell method, whatever the shell method is, the axis of rotation is horizontal, it will be perpendicular to it. If it is perpendicular to it, this has to be dy. So the shell method here, for the horizontal axis of rotation, this one horizontal, and the shell method will be perpendicular to it, so that's going to be dy. So 2 pi RH, and we use dy, and look like the limit will be from 1 to 6. If we zoom in the graph, you will see we don't need to do that. Okay, yeah, so 1 2 3 4 5 6. One to 6. Right. So we have that. What next is to find h. We're going to draw the line parallel to the axis of rotation. Parallel to the axis of rotation, and then we write the boundary on the right minus the one on the left. So the the h, that region R, I should not write anything there. Very confusing. The height from the right minus the left. On the right, it has to be in terms of y. So if y is equal to 6 minus x, so for x we have x equal to 6 minus y. That function on the right minus the one on the left. 0. So that's just 6 minus y. 6 minus y for h. Now for r, pick any point on the line that we just wrote, just wrong, x and y. And then from that point, there's the x coordinate for that point and the y coordinate for that point. We have to use the y coordinates, which is this distance here. And then after we do that, what will be the radius from that point to the axis of rotation? So that also happen to be y. So we have from 1 to 6, 2 pi, r is y, and h is 6 minus y, dy. Right. Go from 1 to 6. Leave out the pi. And then stick the pi at the back. 200 over 3. Stick a pi to it. Right. So just enter the answer. Right, the integral will have the dy that goes from 1 to 6. Two pi y minus 6. What? Just copy from one place to another. Right, we're good. Yeah, on the test you only have one chance to enter the answer. So make sure you double check before we hit error. Right. Next we have that one. Alright, this is the problem I created. The problem that I created, usually there will not be the calculation. Just okay. So, and also on the problem that I create, usually I will give you the graph, so you don't have to worry about it. Y equal to 1. And x equal to 4. So we have that. Yeah, I don't know what happened before. It's a lot smoother now. The video quality, that is. Right, axis of rotation. Rotate about the line y equal to 4. Right. This is the axis of rotation. And we want both this washer and then shell. Oh, sorry, not supposed to do that. Right, so this and a washer first. So horizontal axis of rotation, and we're going to go along the axis of rotation. This washer will be dx. That is pi r square minus little r square dx. Right. And then the limits for x 0 to 4. Now just determine the big radius and the little radius. So the big radius is from the axis of rotation to the outer edge, bounded above by 4, below by 1. So the big radius is 4 minus 1, which is 3. The little radius will be from the axis of rotation to the inner edge, the closer edge. So be above by 4, the bottom by square root of x plus 1, which gives us 4 minus 1 is 3 minus square root of x. Yeah, negative, distribute. Multiply it out, that will be negative 1, 4 minus 1, 3. Right. So we have big R, little r. That's good. So for this washer method, 0 to 4 pi big R 3 square minus 3 minus square root of x square dx. Right, so that is the disk or washer method. It is the washer because there is the hollow region. Now go to shell. The shell method, if one of them is dx, the other one is dy. That's for sure. But the dy, I mean the shell, will be perpendicular to the axis of rotation. So axis of rotation is like that. So we go perpendicular, which is going to be dy. y goes from 1 to 3. That easy. So shell method, 2 pi big R bit h and dy in this case, which y goes from 1 to 3. Right, now how do we determine R and H? Right, what we do is we're going to draw the line parallel to the axis of rotation. Right, and not really parallel but have to be within the boundary on the right minus the one on the left. The one on the right is going to be 4. The one on the left will be this function, but we have to solve for the function is y. So from here, move the 1 over and square both sides. And this is the function that we use, the function that is on the left. So that is R. That is H. Now to determine R, pick any point randomly on this line. Any point will do. I choose this point. When we have that point, we will have the distance to the y-axis is going to be x. The difference to the x-axis is going to be y. Since we have dy, that's what we need. So this distance is y. Now the next question is to determine R. R is the distance from that point to the axis of rotation. So this one actually is going to be R. That is the distance R. So how do we find R? Well, the total is 4. Take away y. Give us the R. So R is that much. So integral will be from 1 to 3. 2 pi 2 minus y 4 minus y minus 1 square dy. Right. Let's see if I got the correct answer here. Right, so this Washer method is going to be dx. So that's that's the first one. Right, we have the dx and the pi already. All we need to enter is inside that will be 3 square or 9, doesn't really matter. Let's try 3 square minus 3 minus square root of x square. Notice there's a big bracket already, so we just need to enter that. And the shell method, two pi is there already. 2 minus y, open parentheses, 4 minus y minus 1 square, close. Close. Check. Oh, should I just enter the wrong number here? Did I enter it wrong? It's supposed to be 4. Yeah, I put it wrong. Oh, same thing. I try that again. Yeah, I write that correctly. Let's use 9 instead. Yeah, just copy from here to there. Unbelievable. See, what did I forgot to close the parentheses? By the way, if it happened to this to you on the test, if you happen to forgot to enter the parentheses, I forgot to put the parentheses there. I will count that as the right answer. Don't worry about it. Let's go to the next one. It's extremely difficult to make sure everything runs out smoothly. Right. 6, 5, and 11, which is up number 18. Alright. The arc length of y equal to 2x to the 3/2 on 0 to 4. Right. So the arc length is square root of 1 plus derivative square could be dx, could be dy, but if we use x, it will be dx. So we just need to find the derivative and put that in here. Should be simple. Right, what is derivative? That is the function. Derivative is 2 times 3/2 x. 3/2 minus 1 is 1/2. So 2 and 2 cancel out, 3x to the 1/2. Right, so that is the derivative. Put that in here. Integral from 0 to 4 square root of 1 plus 3x to the 1/2 square dx. So that gives us square root of 1, 3 square is 9, x to 1/2 square just x. So we just need to do that. Yeah, I want to try to move this thing, really distract. Right, anyway, the answer is multiple choice, so and none of this can be given by the calculator, so we'll not be able to do this using the calculator. So first, let's use substitution. Take derivative, move the dx, and divide by 9. Pretty standard substitution. And then the limits. X equal to 4, x equal to 0. When x equal to 0, put 0 in here, u is equal to 1. When x is equal to 4, put 4 in there. And then yeah, so that's 37. So the limits, instead of going from 0 to 4, it goes from 1 to 37. We will have square root of u. And dx is du over 9. I take the 9 constant outside. And then we write u as the 1/2. And then let's integrate 1 over 9. U to the 3/2 over 3/2. 1 to 37. Multiply reciprocal, 2/3. And then we put in 37. By the way, that will give us 2 over 27. And put in 37. And then put in 1. One to the 3/2, of course, is 1. Right, and we factor out 22 over 27, and with that we should have the 2 over 27, 37 to the 3/2. Oh, 3/2, not 2/3. That should be B. Right. Right. With that, we finish on the chapter 6. Now we go to chapter 8. I thought that I will share this after we go over this, but since I checked my email and nobody asked any homework questions, so I have time, and so we just keep rolling with this. Right. So we have the problem. Determine if this is integration by parts or using substitution. Right. So that is the problem. So integration by part or substitution. So usually, if we let's talk about integration by parts first. Usually, integration by parts, we have to have the parts that can be integrated, and the part that is differentiated. So one derivative, one integral. And the way we choose u, the part that is differentiated, is going to be in this order. So there's no log, there's no inverse streak, there is the algebraic expression. So that will be x to the 9 if we have to do that. So that u is equal to x to the 9. And this to be differentiated. However, if we do that, we won't be able to integrate the cosine. So if we do that, then dv is equal to cosine equal to negative 5x to the 10 plus 8. This by itself cannot be integrated. So because of that, integration by parts doesn't work, because we cannot integrate this. In order to integrate this, only one way to do that is substitution. So this is a substitution problem where u is equal to negative 5x to the 10 plus 8. Right, that is correct. Right, next. Almost kind of the same thing. Just very subtle change. Now, iteration by parts or substitution. Right. Now, just like there's no log, no inverse trig, so algebraic expression or polynomial, yes, so let u equal to x to the 8, right? In that case, dv is equal to cosine of 5x. The question is, can we integrate for cosine 5x? The answer is yes, that we can integrate. So in this case, it is integration by parts, where u is equal to x to the 8. However, if we want to try and see if we actually can use substitution here or not. If we use substitution, let's just try u equal to 5x. So for the derivative, du is 5 dx, du over 5 is dx. Now substitute back in x to the 8 cosine of u and du over 5. And we have a big problem. The integral is supposed to be in terms of u and the x to the x left. So substitution fails. So we have to use integration by parts, where u is equal to x to the 8. Yeah, that's correct. Determine pretty much same thing. Ln of 6x is dx. So LIATE, there's a log, so u will be equal to ln of 6x, and there's nothing left, so dv is dx. Oh. Whatever dv is, you have to have dx there. I'm sorry. And dv is dx, then obviously we can solve for v. We integrate and then give us 1. So it's certainly doable. Right? So this is integration by parts. Because we can differentiate, we can integrate. Besides, that integral, we don't know that. If you check all the formulas, it's not immediately given. So this one is integration by parts, because we don't know how to integrate ln of x without integration by parts. And that's also correct. The next one, yeah, why I have a bunch of this. Right, so again, integration by parts, LIATE, and this is a log, so that certainly works. But remember, the integration by parts, this is u and dv, and that is multiplying. the ln is supposed to be multiplied to it, but this one divided by. So this one automatically is the substitution, because we have the ln at the bottom. If it is like ln of x times x to the 10, for example, this is automatically integration by parts, because we have ln of x times something. This one divided by ln of x, impossible to use the integration by parts. So substitution, u equal to ln of x. Yeah, so one is multiplying and this one divided by. So even when we have, let's say if we have the problem ln of x cubed and let's say times x dx, I mean divided by x. If this is the problem, then it will be substitution as well, because we can only have ln of x. It could be ln of 3x, still okay, but we cannot have the power of ln of x or divide by ln of x. When we see that, for this case, it's going to be substitution. Right. So now how do we actually do the integration by parts? What numbers? Okay, 23. Evaluate. X sine of 12x. Right. Remember, in class I will use the table. So u and dv, or not even u and dv, I just said something to be differentiated and something to be integrated. And the part for differentiated will be using this. So there's no log, no inverse trig. There is a algebraic expression, so it's x. And then sine of 12x will be here. Alright, differentiate 1, 0. Integrate. Integral of sine is negative cosine. And then divide by 12. Negative. And then integrate that is still negative 1 over 12 and times 1 over 12 sine of 12x. So negative 1 over 144 sine of 12x. And integration by parts, we will use the diagonals. The first one is the plus, the second one is minus, and alternating forward. Right, x times negative 1 over 12 sine 12x, sorry, cosine 12x. And then 1 times that, so minus negative 1 over 144 sine 12x plus c. Let's rewrite this as negative 1 over 12 x cosine 12x plus 1 over 144 sine of 12x plus c. Right. Yeah, this problem does say we just use integration by parts. What happened? Oh. Right. This is also integration by parts. to be differentiated, to be integrated. Right, Liate, right, there's the at. Take derivative with respect to t, h and 0. Integral of e to the t is e to the t. By the way, we do not need to go any further because that is 0 going forward. Right. Diagonals. The first one is positive. The second one is negative. So at times e to the t. First diagonal. Second diagonal is negative 8 e to the t. And the next one would be positive, but that could be 0 anyway. So we have 8t e to the t minus 8 e to the t. At e to the t minus 8 e to the t. And it said, do not forget the don't forget the constant c, arbitrary constant c. Okay. If you forgot that on the test, that's all right. Oh, this is 25. Evaluate. This is also integration by parts. Right. And I prefer to use the table. A part that is differentiated, the part to be integrated. And let's see, Liate, there's algebraic expression. Right, take derivative until it vanishes to 0. And then the other one, integrate, will be 1 over 7 sine of 7x, 1 over 7, and then divide by 7, negative cosine 7x, 1 over 49, negative 1 over 49 cosine 7x, and then also negative 1 over 49 cosine 7x is 1 over 7 sine of 7x, and so it's negative 1 over 343 sine of 7x. Right. So integral of cosine is sine, integral of sine is negative cosine, and yeah, because of 7x we have to divide by the coefficient. Right. So, and then diagonals. Let's see, do we have to simplify this problem? That's mine. X squared 1 over 7 sine of 7x, and then subtract 2x, and then that negative 1 over 49 cosine of 7x. I'm just trying to type the whole thing like this and see if it works. And then so plus, minus, and then plus 2 negative 1 over 343 sine of 7x. I'm just trying to see if it works. X squared 1 over 7. And just put multiply, which is the asterisk. And then the asterisk sine of 7x minus 2x minus 1 over 49 cosine of 7x plus 2 negative 1 over 343 sine of 7x plus c. Actually, they take that. We don't even need to simplify. Minus negative, so that plus. So my MATLAB actually they take anything that is equivalent. How many of this do we have? Also iteration by parts. Differentiated and integrated. Right. So on this one, on that checklist, the first thing we say is ln of 9x. And then the other one is of course 12x. Right. One to be differentiated, the other one is integrated. So differentiate the ln of 9x. We use the chain rule. Ln is reciprocal 9x and 9x. And so which is 1 over 9x times 9. 9 cancel out. So that's just 1 over x. Yeah. Just 1 over x. And integral of 12x is 12 x squared over 2, which is 6x squared. Right. So we have 1 over x here. And that. Notice if we keep differentiate, it would not go to 0. So we have to stop at some point. So first, positive. So we start with that line, ln of 9x squared, ln of 9x times x 6x squared. And then we cannot just keep doing the diagonal like this. We have to stop at the second step. When we stop with the horizontal line, it will be the integral. So we will have subtract. The first one is positive, second one is subtract. And multiply 1 over x and 6x squared dx. So we have 6x squared ln of 9x minus, to cancel out, 6x dx. So 6x squared ln of 9x minus 6x squared over 2. Let's see. So we'll have 6x squared ln of 9x minus 3 x squared. Let's see. minus 6x squared ln of 9x minus 3x squared plus c. Right, that's correct. Right. This next one I guarantee will be one of this will be similar, will be one problem similar to this on the test, because this is one of the classic problem. The type of this is we have one of the exponential, one exponential and the trick. So either e and then sine or e and then cosine. To be differentiated, to be integrated. Alright, classic problem. Right, so LIATE, LIATE, no log, no inverse trick, no algebraic expression, but this is a trick. So we go with sine of AX here, A theta, and then e to the negative 4 theta on the other side. Right. One of them is differentiated, the other one is integrated. Derivative of sine AX is 8 cosine A theta. Derivative of that, 8 cosine will be negative, so 8 negative 8 sine A theta, negative 64 sine A theta. Integral 1 over negative 4 and integral of that again. One over 16 e to the negative 4 theta. Right. So we have 1, 2, 3, and 4. Right. I mentioned before, classic problem. So the type of classic problem usually have the classic solution. So for this one, it will not vanish, so we have to stop at some point. So first, that's the first diagonal. Let this integral be I, so I don't want to write all of that again. Alright. Sine of A theta times negative 1/4 e negative 4 theta, and then subtract the second diagonals with the minus 8 cosine A theta times 1 over 16 e negative 4 theta. And then we're going to stop using the horizontal line. The next one is going to be a plus. When we stop, we do the horizontal line and we just multiply those two. Negative 64 sine of A theta (1 over 16 e negative 4 theta). And you say, why do we do it 2 times? And why don't we just keep doing? Or why do we stop earlier? Now, the reason that we have to do 2 steps is because that is the classic solution. But even more than that, remember, original problem we have the e and the sine. Now we have the e and the sine. So somehow we go back to the original problem. And that's the idea of it. Now let's simplify this a little bit. Negative 1 over 4 sine A theta e negative 4 theta. I should write the e first. 8 over 16 is 1/2 minus 1/2 e to the negative 4 theta cosine a theta. And then that minus 64 divided by 6 is minus 4. I put it outside of the integral. And we write the e first. Right. So negative 64 and 1 over 16 is negative 4. And the next one goes that to plus. So that's fine. We write e first and then sine. Now, that's actually exactly as the original problem. So this thing here is I. So let's rewrite this from both sides. The I equal to negative 1 over 4 e to the negative 4 theta sine of a theta minus 1/2 e of negative 4 theta cosine a theta, and then minus 4i. Then definitely we can solve for I. So the classic problem is, the reason this one is nice, because we start with I and we end up with also I. So we can move this to the other side, 5 times the integral, plus 4 of them on both sides. I plus 4i is 5i. And then we divide by 5. So we do not find the integral directly. So divide by 5, the whole thing. So on the test, whenever you see both exponential and the trig function, you know that we have to take it is integration by parts. We do that 2 times to get back to the integral I and solve for it indirectly. Right. The theta is backslash, spell out the theta, and then sine 8 backslash, spell out theta, minus 1/2 e to the negative 4 theta cosine a theta plus c. Right, so that is correct. There will be a few more problems, 4 more problems. I will do that in class. By in class I mean together in the lecture. I'm just going to stop the review at this problem. Thank you for watching. Thank you for watching.